Okay, great.
And yeah, so I will go as a good afternoon or good. We are in China, in Asia, so I'm still in German. A quick introduction to me. So I'm Marcello Tania. I'm a master student in bionics in Germany. So I work at Fab Lab Blue right now. I was working 1 year in Fab Lab or Shanghai, and then yeah. So feel free to ask any questions if you have, and thank you for the one with opening the camera, so I'm not just talking to myself. And if you have any questions, just let me know. Or yeah. So yeah, I'm also from Indonesia. Mm, so yeah, so the main aim for today is actually learning one of my project. I'll show you. I guess I'll show you in real life instead of sharing it with the screen. So does anybody can see my video? Yeah. Okay. So yeah. So I'll show you the code. So here is the things that I'm doing. So let's wait a moment. Yeah. And if you are looking at these things, this is actually run by my little machines here. So I have one little machine. Wait, the cable is not that enough. So the objective is actually we got 1 hour for me having the talk. So I just want you to get a main idea how I'm doing these things. So this is actually the Flappy Birds. I guess everyone is familiar with that. And so what I did is I built these little machines to run those robots to play the Flappy machine. So this is not run by me. So if let's say if I remove this machine, it's just gonna die. So the main objective of this game is actually to not collide between the pipes or landing to the ground. And yeah, we are going to learn how can we make the artificial intelligence using neural networks and evolutionary algorithms. But just don't worry about the terms yet because it's actually not that difficult. Well, it takes time. So yeah, do you have any questions so far? I think Mr. Haru maybe, I don't know, or others. Mm,
Okay, please go ahead.
No, okay.
Okay.
So yeah, our main objective is actually learning how I'm doing this Flappy Bird AI machines. So I've shown you before, and so we can continue. So before going further more, so I'll have quick tips if you want to learn more about this, because I don't think so we can learn a lot of details in just 1 hour. So the quick tips for me is that you can actually uh, code it by yourself because you will understand it better. And then uh, in terms of programming itself, I don't think so. It's a good things if you wonder a lot of things. So it's always better to get hands on the programming. So you can know you'll not always wonder. So you'll always make sure that you know what's the input and what will be in returns and the output. Mm, yeah. So I'll begin with the basically neuroevolution is from neurons and evolutions. So we are going to talk about the biological terms of what is neurons and what is the natural evolutions by the Darwinians, if you are familiar with that. And if you want to take a look more, I have the GitHub for this project. So let's just begin with the artificial neural networks. So in that, my projects, every bird is actually having their own brain. And if you take a look in the small scale inside the brain, you have neurons. And how a neuron works. So first, it takes an electric input, and then it goes to the axon. This is called an axon, and then it pops out to another electrical signals via terminals. And in biological neurons, it doesn't produce an output that is a simple linear function. Oh, sorry. Yeah. Moment. So, for example, you in the neurons you have also a threshold. So when then there's an observations that suggests that neurons do not react immediately. They have a terms what we call thresholds. So for example, when the input has grown so large, and then it triggers an output. So it only produces an output signal if the input is sufficiently dialed up to pass the threshold. So you have the threshold here to have an output. And in terms of that way, so you can take a look that this is the step functions and you have a threshold. So the when the neurons has enough inputs more than the threshold, it will generate output, which is you can take a look the step functions. However, in nature, it is very you have step. Therefore, you have more something natural and realistic. And oh, okay, at the end, this is what we call the sigmoid functions. So you have something more smooth. There's no hard edges in mostly in nature. And so biological neurons, it takes many inputs, not just one. If you sum this up, so you have input A, input B, so you got a sum of A plus B, and then you put again into that sigmoid functions that we talked before, and you get an output Y. Yeah, so this shows how the neurons connected more biological. And in neural networks, this is how it works. So it works with many neurons connected together and giving signals and so on. So this is how the biological neurons and looks like. And but instead of having it uh, like these things, we are trying to model it more mathematical, so we can just program it and translate it into a code. So first, you have 3 layers of artificially neural networks, and so you have some inputs, and between layers, we have what we call a weight. It's like how strong and how much does it relates to go to another layers. So this is the weight is actually deciding how important that is to go to another layers of the things till the output. And so I have very simple examples right now. So right now we the wi comma y is so those are the weight that I'm just saying it, giving a random value. And then we have the input two inputs. One, the first one is 1, the second one is 0.5. And then now what we have to do is calculate the outputs. I'll just give you an examples how to do that. So I have a pen here. So what will be the output of the first one here? So how to calculate it? So it's just simple math. So 1, which is the output, times 0.9 plus 0.3 times 0.5. So this is how simple neurons works. So when you see in biological, and now you are translating into math, so the output of the first one is just 1. The input is 1 at times 0.5. So this is 0.5 times 0.9. And 0.3. I'm so sorry. So this is input 1 here. This is input 2 times 0.5, and the weight is 0.3. So you got the output of whatever that value here in the first output. The same thing again for the output 2. So this is x1. Now I'm also need to calculate what will be the x2. Oh yeah. So after we got the x, we have to put it into this sigmoid function. So what will be the, I think I have the value already. Yeah. So here, 1 times 0.9 plus 0.5 times 0.3, then you'll get this value 1.05, and then you put it into the sigmoid functions, then you'll get 0.7408 as the results of the functions. And also the same thing like the second output. So 1 times 0.2, because you have this 0.2, plus 0.5 times 0.8. So at the end, you get 0.6. You again put it into the sigmoid functions, and you get this much as value. So that is how the artificial neural network works in the code that I did. Just simply as that. So do you have any questions? Is that clear? I don't know if I'm doing it too fast or too slow. Okay. Yeah. Okay. Okay. So I think this is pretty basic high school math, isn't it? So right now we put it like this way, right? X and then another X. So when you have two equations, when you have two layers also, And then we can also just put it into a matrix form. So you have on the left side all the weights times the input, and then you'll get the x. So the weight times the input, then you get the x, and then the output will be simply the sigmoid functions of x. The same things, but you just put it into a matrix. So matrix multiplication is useful because you'll have a lot of neurons, not just one. So you put it into matrices. So let me know if you are getting lost because I'm pretty. Okay. So before you have two layers. Now we are what I did all in my Flappy Bird AI machines. I did a three. I also try with the three layers. So first we have what I call X hidden, and then weight input hidden, which is all these weight from between layers 1 and layer 2, and then the input, which is all the inputs here, and then you got the output here, which is I called it O hidden. So you have output from the in the middles of the layer 2, and then from that you put it again to form an X output for the third layers, and then finally you get the output here. So yeah, so before it was two layers, now we are making it into a third layers. And I yeah, I think it's pretty fast. So that's all for the artificial neural networks. So just keep in mind that is how the simple artificial neural networks translate it into a function. So yeah, now it's another topic. So it was neuroevolution, neurons and evolution. So I think before introducing an evolutionary algorithms, I want to ask you someone like, what do you guys know about evolutions in biological terms? Not just uh, uh not just it was I guess it's quite famous. If you guys know this guys, he's one of the biggest name in science, and he's also having a very big piece of discovery about natural evolution. So he's a Charles Darwin, and he wrote a book in 1859 on the origin of species. I think I'm just gonna write it here. So evolution. So he has many aspects actually. So his discovery was about evolution, and in this book, they summarized the four key concepts of evolutions, and I didn't put one because I will explain you why. And but these are the three that I'm using for my evolutionary algorithms. So first, one or more populations of individuals competing for limited resources. So if you look at the natures, this Charles Darwin was having these observations that one or more populations of individuals competing for limited resources. So those limited resources are actually, for example, lack of food, lack of mates, for instance, or lack of um, places to live, I guess. So uh, that makes the first key concept, and also that makes it hard for people who doesn't have a fitness, who is not strong enough to actually being killed by someone who is actually stronger, and they get more food. And it brings us to the second concept of fitness, which just reflects the ability of an individual to survive and reproduce. So what does it mean? The concept of fitness in evolutionary algorithm is actually very important. So the one who is having a stronger genes is the one who can survive. The one who is strong enough, the one who can be able to run away from predators, for example, a rabbit, from an eagle, the one who can like jump, run, or go run faster is the one who will most likely to survive. And then the third concept is about the parents will reproduce their offspring, but the offspring is not going to be identical. For example, that my parents and me, they are similar, but they are not identical. So, and I use two concepts with more details in my programming. So I use what it's called mixing. So they are they are I have mom and father's genes. I combine it to form an offspring. And then there's also what we call mutations. So we slightly modified the genes, hope and with the hope that um, my bird is playing better than before. Yeah, and then so now I'm just gonna show you how I did. So that's like a very quick introduction, by the way. Mm, So I'm so that's all about the theory. Very and then now I did very nice. So can you see my screen? Yeah. Okay. Yeah. Thank you for the feedback. So now before I think I just cannot explain it everything. I don't think so. You can understand it nicely. So I just give you a very quick and easy examples. So we have a function here, which is 2x minus 3 times x again minus 12 times x plus 1. So this is how the graph looks like. And the problem set is actually finding the global maximum. So I have to find the global maximum of these functions using an evolution algorithms. So, from those key concepts, we have several steps. So the first one is actually how can we represent an individual, and then the second is how is choosing parents. This is the pseudocode how to do an evolution algorithms. And the third one is create an offsprings mutations. The fourth one is compute the fitness of the offspring. The fifth one is select a member of populations to die. And then you just repeat those steps for the next generations, and then finding the solutions. So I will talk about that one by one and go through it. So again, yeah. So this is the functions, And how can we represent this function? F of x and then x. So the phenotype is the characteristics of an individual. So you can think an easy characters of a human, for instance. For instance, you have hair colors, eye color, skin color, height, or weight. So that's what we call phenotypes. And in this function, I called my phenotype, which is the y-axis. Yeah, sorry, the x-axis is the phenotype, and then the y-axis is my fitness. And fitness is like who is the strongest is like is gonna win. So those are the fitness. So y-axis is fitness, the x-axis is phenotype. And then now I will have to create my first populations. By doing that, first of all, I need to create the first individual. So randomly. So this is just a functions, how you created a random float functions, point numbers from -2 to the third. So I limit myself space between -2 till 3. And then my population is gonna be just 10 individuals, 10 people I'm using. But right now, first, initially, I created the first individual. So this is just a simple random numbers in this function. And when you print it, I get 1.967. And then the fitness, again, this is the fitness is the y functions. So this is my fitness panel to fitness, which is my functions. So you got -18. Yeah. So those few lines you have successfully created the first individual, and then you just need to create 10 individuals. So these are the tables of your first populations with 10 individuals, and these are the phenotype and the fitness. And the next one is actually we are creating the statistics. So we want to know where where is the global maximum. And after that, yeah, so we got the best fitness is 7.9, which is the fifth individual. And the x is -10.7. So you might be want to find this value, for instance. That's what we are looking for. And then by those 10 individuals, we can just randomly choose a parent. So this is the integer value again. We are going to choose a parent from those 10 individuals from 0 and 9, and we choose a parent 0. And we also introduce what it calls mutation. So you try to mutate it a bit, but not that much usually. And this is how you create the mutation. So you add or minus 0.1 steps. And then if it goes outside the boundary, it's just going to be bounced back. So maybe it's a bit too fast. You can take a look at the codes later. I will share you the link. And again, compute the fitness, which was the fitness, and then select a members of the populations to die. So this is where you comparatively you choose the rifle and then the offspring randomly, and then compare it. If the rifle is actually stronger than the offspring, and then you replace it for the next generations. And yeah, this is the final thing. So I was trying using, I think, 50 50 generations, and this is my graph. So you can take a look at as the following. So the 0 generations on the average fitness. This is average fitness is where you sum all the individual fitness and divide it by the population size. And you can take a look that the average fitness it increases over time. Because it's quite a simple problem, so you get the best fitness almost you almost the solutions. So you can take a look at here actually that the global maximum is around 8, and we can take a look and we can double check if it's actually correct by just looking the function. So it's around here 8. And then furthermore, so those are a very simple evolution algorithm. And furthermore, I introduced what we call genetics. So genetic. So I'll just give a quick thing. So I'll show you. Hello. Oh. Okay. I don't know. Yeah. So as a quick review again, phenotype is the collection of all traits of an individual, for example, hair colors, eye colors, and so on. And then when you go to a genetic algorithm, is if as you know that we are made out of DNA, and those DNA has a genes. Also, this is what we call adenine, thymine, those kind of stuff. And this ideas is actually leads to another algorithms, what we call genetics algorithms. So we can make like this genetic DNA, those kind of genes, into a form of functions using a binary thing. So you have, for example, 4 bits, and you can translate it into a phenotypes. So what I did was actually similar. So now I have certain of genotypes like a bits 0 and 1, and then I translate it into phenotype. Then I do again a lot of simulations to form the solution. So I got the same, the similar solutions. And what I did in my Flappy Bird machines was actually use that genetic algorithm, this one, as an array. So I have not just one dimensions, but I have multiple dimensions. Those are the weights of my artificial neural networks. So I did the same concept, the like the one before I explained it before. So I guess, do you have any question, or should I just show you again? the code. So I think that's too fast, I would say. So these are also the hardware. Yeah, I guess that's all. So as you can see here, you have also generation. So this is the second generation. This is the best fitness 36, and then these are the schools. This is the individual. So I guess I have 10 individuals. So this right now is the fourth um, bird that is actually being trained. And I would say I'm open with any questions if you have any doubt or things or or any feedback, of course. Yeah. Do you have any questions? Or
Yes, I have a question.
yeah.
Can you hear me?
Yes.
Okay. So in your system, controlling the servo motor
Mm-hmm.
in accordance with the game spring,
Mm-hmm.
the bird is hopping just like this. And
Yeah.
my question is how to detect the position of the bird?
Yeah. So what I did actually I'm using a library in Python. It's called pygame. So I have 5 inputs, which is the height. This is my bird, and I have 5 inputs, which is the x here, the distance between the pipes and my Flappy Birds, and the distance between the 2 pipes, and then the height of my Flappy Birds. So from those inputs, I put it into a neural networks, then get somehow get calculated by the weights that was being reproduced by the evolution genetic algorithm, and then output is just actually press and not press the motors. So is that clear? Yeah.
Okay.
So and then I translate. I use the USB serials to give the output to my cell phone motor. So I first I simulated into a games. Anything else?
Thank you.
Yeah, I guess it's really hard to understand it, but if you want to understand it better, is go take a look the codes and try it, and then hopefully you can do something else with other robots. Or I think you have also there's also a cool stuff, not just a softwares like this. NASA also in 2016 they produced an F4 antenna. So this is 2006. I'm sorry. So one of the missions in NASA they use a spacecraft. They produced this form of antenna using an evolutionary algorithm. And then by this, he can use the optimized patterns of antenna to perform it better. So this algorithm is quite useful for optimizations. It can be software, hardware, and those kind of stuff. Yeah. Oh, wait. So thank you. I think I'll stop recording. Maybe if you are not comfortable.
Okay,
Yeah.
thank you very much.
Yeah, thank
Yeah,
you.
really interesting.
So, I